Welcome to lecture number 24, section 4.4. So this section is about quadratic equations. Alright, so a quadratic function is any function that is defined by an equation of the form y equals ax squared plus bx plus c, where a is not equal to 0. And I want to put a small input here, equation. Alright, so one thing to note here is the a, b, and the c values are all going to be actual numbers. For example, you might see an equation that looks like this. 2x squared plus 3x plus 4. So those are just placeholders for where actual numbers would be. So we're going to go over 3 different methods for solving quadratic equations. Alright, so I would say these go in terms of possibly from simplest to maybe more the challenging one. Square root property is the first one we'll look at. Then we'll look at zero factor property. And finally, the quadratic formula. Alright, probably a well-known word there. So the square root property. If you have an equation in one of the two forms, so x plus or minus a number squared equal to another number, or x squared equal to just a number, you can use the square root property. And what you do is you take the square root of both sides, and then you need to add a plus or minus to include the two possible answers. And I'll go over why we would add a plus or minus. So here's the question. What number times itself twice gives us 4? Here's a visual example of what I'm asking. A number times itself gives us 4. So think of the number. Well, let's see, one number I can think of is 2 times 2 gives me 4, right? There is another one that would give us 4. How about negative 2 times negative 2? Would that give us 4? Yeah, it would, because the two negatives would cancel each other out. So in reality, if you had a number times itself, which we could write as just squared, equal to 4, that number is either a positive 2 or a negative 2 squared would give us 4. This is why we include the plus or minus when we are solving, because positive times a positive would give us our answer, or a negative times a negative would give us our answer. So we need to include the possibility of our answer being positive or negative. Example 1. Solve the following quadratic equations using the square root property. Alright, so first off, let's check. Is this in the form for the square root property? Well, we have our x value squared equal to a number. So let's go ahead and use the square root property. So what we do for the square root property is you take the square root of both sides. That will then cancel the square on the x, so we'll be left with just x equal to. But when we do this, remember we have to put in the option of having either the positive or the negative answer. So to show that, we add in the plus or minus. And normally you add it to the side that is not where your variable is. Alright, so we need to include that. Remember, that is very important because that means there are two answers, not just one. So x is equal to plus or minus the square root of 4. Can we simplify the square root of 4? Yeah, we can. So x equals plus or minus 2. And that is our answer. So if you had forgotten to do the plus or minus, you may have just answered x equals 2. But remember, there are two answers, so you've just lost half the answer. So that's a big no-no, so please remember the plus or minus. Alright, let's take a look at b. Is b in the form for using the square root property? Well, if we look up at the examples here, remember, x plus or minus a number, which we have here, n plus or minus a number, squared equal to another number, which we have. Alright, so we have all of the qualifications there for using the square root property. So we can go ahead and just square both sides. Okay, when we do that, cancels there. And we are left with n plus 5 equals plus or minus the square root of 9. Well, we can simplify plus or minus the square root of 9, so we get n plus 5 equals plus or minus 3. Now, I'm going to try and get n by itself, which means I need to add 5 to both, subtract 5, sorry, from both sides. Now when we do this, be careful. Normally, you put whatever you're adding or subtracting in front of the plus or minus, okay? Please note that. We'll put it in front, and you'll see why in a sec. So now we have n equals negative 5 plus or minus 3. That's a 3. This means we have two possible answers. Remember the plus or minus. N is either equal to negative 5 plus 3, or n is equal to negative 5 minus the 3. Okay, we can go ahead and simplify those. Negative 2, negative 8. And those are our two possible answers. All right, let's look at the last example. So is this in the perfect setup to use the square root property? Well, we have our variable minus something, squared power, but then there's this random 16 over here. Okay, so we're going to have to subtract that from both sides. And actually, sorry, I need to make an edit on this problem before we continue any further. That should be a plus sign on that problem. So please go ahead and add in that, minus sign. Okay, that should have been a minus. All right, once again, we're trying to make sure this is in the right form for using the square root property. So to do that, we're going to go ahead and add the 16 to both sides. Then we get y minus 2 squared equals 16. So now it's in that perfect form. We have our variable squared equal to a number. Okay, so we're going to go ahead and now we can apply the square root property. Let's square root both sides. Remembering that plus or minus, very important. The squares cancel and we are left with y minus 2 equals plus or minus the square root of 16. We can simplify that. Y minus 2 equals plus or minus square root of 16 is 4. So to get y by itself, let's add 2 to both sides. Once again, normally you put it in the middle there. Then y equals y equals 2 plus or minus the 4. This we split into the two possible answers, the 2 plus 4 or the 2 minus the 4. Simplifying out, we get y equals 6 and y equals negative 2. All right, so that is the square root property, and it tends to work best when you already have just the variable squared and there's no regular x value. So it works best if it's in one of these two forms, okay? But our equations are not always in that form, so this method, the square root property, does not always work, which means we need other properties. All right, so hence we have another property, solving a quadratic by the zero factor property. So the name, the property, kind of tells you what to do. You're going to set their equation to 0, and then you're going to factor the polynomial. Once we do that, we set each factor to 0 and solve for our value. Okay, so note, in this class, we're only going to be factoring quadratics where our a value is equal to 1. There are times in future classes where your a value will be a number greater than 1, but for this class, we are focusing on a values equal to 1, which you'll note all of them here. The a values are always 1. Okay, so when I'm factoring a quadratic, what I want to do is first I'm going to set up my binomials. And I'm going to focus on the n value first and see what factors there are. So this is a 4. What are the factors of 4? Well, we have 1 times 4 and 2 times 2. Those are the two possible factors. Okay, so now what I want to figure out is how can I, and this is where we use our words here, how can I add to get a positive 4? So let me change that lettering there. Okay. So let me write that out. How do I add to get factors of 4? Sorry, not how do I add to get factors of 4. How do I add to get positive 4? Okay. And I got the add from the addition value right there. And I got the word positive from right here. If this had been a negative, I would have said negative 4. Okay, but it's positive. Okay, well, let's see. If I add 1 and 4 together, that gives me 5. So that factor doesn't work. If I add 2 plus 2, that gives me 4. Aha, the 2 works. So what we're going to do is you write x into x, and then we're going to do the plus 2 and the plus 2. And there we go. We have factored. Okay, if you wanted to check if your factoring was correct, you could go ahead and use the distributive property and see if you get the same trinomial as the top. I'll go ahead and try that one with this problem. And we won't do it on the other ones because the video is focusing mainly on just the factoring. But I'll go ahead and show you how to check with this problem. So for checking, we're going to go ahead and use the distribution property. So x times x, and then the x times the 2. So we get x squared plus 2x. Okay, done with that x, then we're going to go ahead and distribute the 2. So we'll get plus 2x again, and then plus 4. When we simplify this, we get x squared. We have the like terms there, plus 4x plus 4. So is that the trinomial we started with? It is! Awesome! So we've checked, so we know that our answer was indeed correct. We factored correctly. So that's the way you can check to make sure you factored correctly. Alright, so we're going to go ahead and factor this trinomial. So setting up my binomials, I'm just going to go ahead and plop the n in the beginning. We just do that because the n value is 1, so we don't need to worry about that. Now, what are the factors of 10? We always pick the factors from the value without a variable. Well, factors of 10 are 1 and 10 and 2 and 5. Okay, that's it. So now we're going to write that sentence like we did before. Let's see how the words change, though. So we have a minus sign and a plus sign. How will this change our sentence? Well, the question is, how can we subtract to get a positive 3? Okay, so that's the new one. We're trying to figure out how we can subtract to get a positive 3. Oops, I actually color-coded that wrong there. Let me redo that. Color coding, we're doing subtracting and positive 3. Awesome. Okay, so let's go ahead and look at the factors of 10 and see if we can do any subtractions to get a positive 3. Well, 1 minus 10, that's negative 9, so that's not what we're looking for. How about, let's do the other option, 10 minus 1. That gives me positive 9, also not the option we're looking for, so that factor doesn't work. Let's look at the 2 and the 5. One option is we do 2 minus 5. But that gives me negative 3, so close. Let's try the other option, 5 minus 2. Well, 5 minus 2 gives me that positive 3. Alright, so we're going to go ahead and plug those in. The 5 was positive. So for now, it doesn't matter which one you fill it into. You could do this side or this side. The reason it doesn't matter right now is because both of these ends just have a positive 1 in front. It will matter when you start working with trinomials where the a value is not just 1, but for now it will not matter. Okay, so we have the positive 5 and then the negative 2. And there we go, we have factored our trinomial. Okay, you can pause the video and try factoring this one by yourself and checking in with me in a sec. Alright, so for factoring this one, we look at the end number to see what factors we're playing with. So for 12, we have 1 and 12, 2 and 6, ooh, and 3 and 4. We got a lot more factors going on here. Now let's create our sentence. We have a subtraction and another subtraction. So what is this saying? How can we subtract? Okay, so the subtract came from the yellow part there. How can we subtract to get a negative, and what is that? Oh, that's a 1, a negative 1. Okay, so how can we subtract to get a negative 1? So once again, we're going to go play around with the factors of 12 to see how we can get a negative 1. Well, I know 1 and 12, that's not going to work. The difference is too big. 2 and 6, well, 6 minus 2 is 4. That doesn't work. And then 2 minus 6 is negative 4. That also doesn't work. Okay. So that factor also doesn't work. Let's look at the 3 and the 4. 4 minus 3 is positive 1. Okay, we're not looking for a positive 1. Ooh, but 3 minus 4 is the negative 1. Bingo, we found it. Okay, so we had to play around a bit with the factors of 12, but now we found it. Once again, I'm just going to plug in the values of x. Doesn't matter at this point because the a value is just a 1. So let's see, let's plug in the factors for 12. So we had the positive 3. Remember, we can put it in either one at this time. And then we have the negative 4. All right, there we go. We are good. We have now factored the following quadratics. So now we're going to apply the factoring to actually solving a quadratic equation. Okay, so for solving by the zero factor property, and once again, on the exam, if you are asked to solve using a specific property, you need to show that you know how to use that property in order to get the full points for that problem. So even if you would get the correct answer, you would not get the full points for that problem because you may have not shown the correct property. So make sure you know how to use all the properties so you can get all of the points on your exam. Sounds good. All right. So let's see. Solve using the zero factor property. All right, let's set this up. Well, the zero factor property means this needs to be set to 0, which at the moment it's not. So we're going to get the 4 to that side. So let's go ahead with that part of the plan. Okay, let's see. X squared plus 4x plus 4 equals 0. Okay, good. We have it set to 0. The 0 part is done. Check. Now we need to factor it. Well, I already factored that above, right here. So I'm going to go ahead and kind of cheat a little bit and write down the factor. Okay, so we have it factored and set to 0. Now the next part we're going to do is set each specific one to 0 and solve. Okay, so let's set each one to 0. Now in this case it actually doesn't matter too much because they're the same, but we're going to go ahead and just do it. So x plus 2 equal to 0 and x plus 2 equal to 0. So solving for x, we'll subtract 2 from both sides. And we get x equals negative 2 and also x equals negative 2. So in this case, the answer actually ended up being the same number, so we can just go ahead and write x equals negative 2. Let's look at the next one. 3x plus x squared equals 10. Well, it's not set to 0, so we're going to have to go ahead and move the 10 to that side. So let's add, or actually we're subtracting the 10 from both sides. And then we get 3x plus x squared minus 10 equals 0. But this isn't quite in the correct form yet because the x squared is right in the middle. We're going to try and move it up to the front. So let's re-scramble things a bit. X squared plus 3x minus 10 equals 0. Awesome, it is set up perfectly. So now we can factor. So let's go ahead, set up the binomial. What do we want here? Well, factors of 10, we know before. In fact, we already did this problem. But I'll go ahead and just do it real quick. So 10 and 10, 2 and 5. We're trying to find something that when we subtract them, we get a positive 3. And I can do that by taking 5, oops, wrong pen, 5 minus 2. Okay, so x plus 5, x minus 2. If you ever need any extra practice or help with factoring, always shoot me an email and ask me questions. I'll be happy to assist you with that. Alright, so they're factored. So the next step is to set each of the individual factors to 0 to solve. Okay, so solving for x on this side, we get x equals negative 5. Solving for x on the other side, we get x equals 2. So we have two answers, negative 5 and 2. Alright, if you want to solve the last one for part C by yourself, go ahead and check in with me in a second. Alright, so this is almost set up for the zero factor property. We just want to move the 5 to this side, get everyone on one side. So we have y squared minus 4y minus 5 equals 0. Ew, that equal sign looks hideous. Okay, there we go. Alright, so I'm going to go ahead and start my factoring. Let's see, factors of 5. So 5, well 5 is prime, so it's just 1 times 5. And then our question being asked or posed to us is how can we subtract to get a negative 4? Let me write that down. How can we subtract to get a negative 4? Question mark. Okay, well factors of 5 are just 1 and 5. So to get a negative 4, we're going to do 1 minus 5, which would give me the negative 4. Okay, let's go ahead and just plop in the y values. So now we know that the 1 was the positive and the 5 was the negative. Okay, so there we go. We have factored our trinomial. Now we're going to go ahead and set each factor to 0 to solve. So y minus 5, set that to 0. Y plus 1, set that to 0. We can do plus 5, y equals 5. And then, solving for the other one, minus 1, and y equals negative 1. Alright, we have found our two answers for our quadratic using the zero factor property. Alright, so we have now learned that property. We're going to go ahead and learn the last way to solve a quadratic equation. Now this is the quadratic formula. I'm going to go ahead and send you a link, or it should be on your La Lima, for a song that you can use to memorize the quadratic formula. So go ahead and check that on La Lima. But the main thing is first you need to set your equation to 0. Very similar to how we were just solving. Then you're going to identify your a, b, and c values. Okay, a, b, and c. And plug them into the beautiful quadratic formula. Alright, so let's go ahead and do that. So looking at a, it's not set to 0 yet, so I know I need to do that first. So let's add the 4 to both sides. So then we get x squared plus 4x plus 4 equals 0. So now I need to identify my a, b, and c values. Well, my a value is whatever in front of the x squared, which is just going to be 1. So a equals 1. My b value is whatever is in front of the plain variable. So just the x is my b value. And then the c is whichever number does not have a variable. So c is also 4 for this problem. Let me go ahead and write, what variable are we solving for? X. Okay, so I know I can write x equals. Okay, so x equals, and the quadratic formula, negative b. So what's my b value? 4. Plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so I've filled them all in. I'm careful to use parentheses because there are, well, that's not supposed to be a b, it's supposed to be a 4. So close. Okay. Sorry, that should have been a 4. Okay, so I've used my parentheses to make sure I don't lose any negative signs. And here we go, we can simplify. So we have negative 4 plus or minus the square root of 4 squared is going to be 16 minus 4 times 1 times 4 is also 16. Divided by, well, 2 times 1 is just 2. Alright, so now we can keep simplifying the negative 4 plus or minus. Let's simplify what's inside the radical. So 16 minus 16, hey, that's 0. So square root of 0 divided by 2. Well, what's the square root of 0? The square root of 0 is just going to be 0. So then we're actually just left with negative 4 over 2. And negative 4 divided by 2 is negative 2. So bringing down that minus sign, where's the x? We have x equals negative 2. So notice, this is the same quadratic we solved for previously, and we also got the same answer of negative 2. So both methods did work. Okay? But remember, you need to know all of the methods and show your prowess at solving quadratic equations. All right. So let's go ahead and solve B. If you want to pause the video, it might be a good idea to try solving this one by yourself. Okay, so we need to get 5 on the other side because we need to set this to 0. So let's go ahead and subtract 5 from both sides. Y squared minus 4y minus 5 equals 0. So what are my a, b, and c values? Well, my a value is 1, right there. My b value is negative 4. Careful, that negative comes with 4. Okay, watch the negatives. And my c value is, a negative 5. Okay, so let's go ahead and write our quadratic equation down. You might be tempted to say x equals, but remember, what are we solving for? We're solving for y, so we're not going to write x equals. Please be careful. Y equals negative b, so negative 4, plus or minus the square root of b squared minus 4ac. So a is 1, c is negative 5. All over 2 times a. Okay, so we have y equals, let's go ahead and simplify that. We have the double negative there, so that's a positive 4. Plus or minus the square root of, well, negative 4 squared is 16. And then we have a negative 4 times 1 times negative 5. That's going to be plus 20. All over, and then 2 times 1 is just 2. So y equals 4 plus or minus the square root of 36. All over 2. Now, simplifying that square root, well, so the square root of 36 is 6. So y equals 4 plus or minus, and remember the square root of 36 was 6, divided by 2. Oh, interesting. Well, we can't simplify any further, so what we're going to have to do is split this into the positive and negative answer. So one option is y equals 4 plus 6 divided by 2. The other option is y equals 4 minus the 6 divided by 2. Okay. Continue to simplify that. We get 10 divided by 2, so y equals 5. And then y equals negative 2 divided by 2, so y equals negative 1. All right, there we go. And let's see, what other options do we have? Okay, so that was it for quadratic formula. So now you know all 3 methods for solving. Let's go ahead and solve an application. So for example 5, we have a formula, s equals 16t squared, is used to approximate the distance s in feet that an object falls freely from rest in t seconds. Okay, so a small drawing like that would be if we have a building, s feet off the ground, you have an object, someone kicks it off, hi-ya. Kicks it off, the ball falls and hits the ground. So, t is the amount of time it takes to hit the ground, and s is the height. Okay, I shall sadly have to erase my beautiful drawing. You have enjoyed it. All right. So, our problem states, if the height of a building is 2,304 feet, how long would it take for an object to fall from the top of the building to the ground? So, we know the height of the building, S, is 2,304 feet. That's the height of the building. And we're trying to figure out how long. So we want t. How long? All right, let's use our equation. S equals 16t squared. We are given s, so let's go ahead and plug that into our problem. 2,304 equals 16t squared, and we are solving for t. So my question is, I know this is a quadratic equation. How do I know that? Well, my variable is squared. Okay, and that's the highest power I see. It's a quadratic equation. So I have three different ways to solve. Square root property, zero factor, or quadratic. I tend to only use quadratic if I really have to because it takes a long time, so I'm going to try not to use that. If I can use the square root, I'd like to because that's the quickest method. So let's see, could I use the square root property on this one? I can, because I just have my variable squared. So I'm going to go ahead and use the square root property. So let's get the variable by itself first. Let's divide both sides by 16. And we get 144. Let me change color on that. Okay, so let's go ahead and square root both sides because it's a zero factor property. Remember to add that plus or minus. And then we get t equals plus or minus the square root of 144. You might go, wait, you just switched the side that t is on. It's okay. We can swap that. Why? Because these two are equal, so it doesn't matter which way I write it. But if it really bothers you, I'll go ahead and keep the t on the other side. But it doesn't really matter either way. Okay, so what's the square root of 144? Well, the square root of 144 is 12. So we have plus or minus 12 equals t. So we have two answers, a positive 12 or a negative 12. Would it make sense to have negative 12 seconds? That doesn't make any sense. So what we're going to say is negative 12 is extraneous. Does not match our problem. We're not going to take that answer. Okay? Doesn't make sense to have negative 12 seconds. So our answer will be, and remember this is a word problem, need to answer in a sentence. The object will take how many seconds? 12. Positive 12, remember. 12 seconds to fall 2,304 feet. Period. All right, let's move on to the next problem. If an object took 9 seconds to fall from the top to the bottom of a building, how far did the object drop? So this time, we're told the amount of time. T is 9. And we're asked to find how far it fell. Well, how far it fell, that would have to be the height of the building, right? Because it's from the top of the building. So that would be S. We're trying to find S. Okay, well, I know my equation. S equals 16t squared. We're going to go ahead and plug in what we know, which is t equals 9. So plug that in there. So S equals 16 times 9 squared. Okay, S equals, and 9 squared is going to be 81. And then what is 16 times 81? Well, that is 1,296. Does that answer make sense? Yeah, it's a positive number, and a building is a positive height. You count height in positive numbers. Okay, so our answer is the object dropped 1,296 feet. Period. Okay, and that is it for 4.4.